In the previous video, I mentioned latching, or the fact that a minus lens will lock the eye in a negative value once you start wearing it. Here is the complete eye as a dynamic control system. This comes from the data by Dr. Smith on the primate eye at birth. And all primate eyes have refractive states about +2 diopters. The same way with the Eskimos who do no close work. So this is a model of the completely normal eye that does no reading, or in the case of monkeys, live outdoors. So let's start with accepting the eyes are normal and dynamic. So what we have here is the input, which is your visual environment. And they can run from 0 to -10 diopters, typically 0 parallel light rays to -6, or reading at -6 diopters. So what the normal eyes does is offset the value of accommodation by 2 diopters. So here's a circuit that does that. Has a gain of 1, and the signal has to be divided in half. So if you're reading at 0 diopters, your output will be +2 diopters, because the offset takes care of the effective near work. It's built into all normal eyes that behave as control systems. So this is the offset signal. And that's the circuit that does the offsetting. Now the Eskimos who did no close work, no reading, no writing, would have a value of +2 diopters. Completely normal. Eventually I'll show that this signal is the reason for the clamping of the accommodation signal. I'll do that separately. So let's say the Eskimos are reading at -6 diopters. I have to exaggerate this for clarity. That means that the eye's refractive state will change from +2 diopters to -4 diopters. Change of 6 diopters. And broad principle, that's the concept of all normal eyes starting at birth. This effectively explains why Eskimo grandparents had refractive states of +2 diopters, while their kids with completely normal control system eyes wound up with -2 and -3 diopters, because they spent 12 years doing close work. The close work did not cause the eye to become defective. No, no, no. It resulted because the eye is using the accommodated signal to control its refractive state. To understand this is to fail a scientific concept, which at this point is pretty well established if you have a scientific mind. So, a little more review. The time constant of the accommodation system is about a second, maybe 3/4 of a second. So that's the time response for the accommodation system, which I made a model of. This offset is established. And here's the eye's long-term control system. Again, established, proven by the work of Dr. Francis Young. The time constant is 100 days. For people who understand control systems, it's got to be that way once you understand it. What this means in effect is that Rafelson's right. The minus lens is not a good idea, but the public in ignorance will demand it when you're 20/40 and wear it. Whether that's commercial, whether people care or people don't understand, obviously Rafelson could do nothing about it, except have his own kids wearing a plus to change this value from 0 to -6 to 0. So when his kids used the plus, this signal was 0 diopters, because the eye is a dynamic system. So if you don't understand this, I can't help, nobody can help you. And people will complain and say, I've got 12 years of school, I'm not going to wear a plus to prevent my refractive state from changing from 0 diopters to -2 diopters. And all I can say is, you don't have a scientific education, or at least don't care, and you don't understand why the signal must be 0 diopters, not -6 diopters. So all through now, the clamping occurs as long as there's a positive accommodation signal 0, there's no clamping. Only when this signal becomes minus does it affect the accommodation system, and you get natural clamping because your refractive state becomes negative, and that's why you have blur on your Snellen. I would expect an engineer designing control systems to understand this logic when the refractive state is -0.5 diopter. Whether they would use a plus lens the way I'm using it for 4-year college, I do not know. I would at least present this concept to them for all fundamental eyes and give them a choice. Either you measure your own refraction to get rid of that accommodation signal, make it 0, or you go down at approximately 1/2 diopter each year you're in college. You can argue these numbers, but that is most certainly the concept. So what is Rupp and Jeff doing? They're changing that signal to 0 diopters. And they expect that the refractive state of their kids will remain positive, and the refraction state will remain positive by some value, and the kids will keep 20/20 through this 12 years of school. So is that a brief summary of the control concept for all fundamental eyes starting at birth, and what could be done for prevention for a person who's gotten down to 20/40 or so? Add your commentary, and thanks for allowing me to correct the issue of clamping. I certainly needed to go through this idea and present it to you. Thank you.